Hello and welcome to MATLAB course. This is ceil. This video is very important video because we are going to summarize all the command, function, character we used at a basic MATLAB function during that course. And I summarized them in 9 pages as follows. So in the first page we have here, like for example, the arithmetic operation, and then the order of mathematical operation, and then some managing command for example, for the command window. And in the second page, how to convert the mathematical expression to MATLAB expression. And in the third page, how to kind of doing the round function for numbers, including the round, fixed, ceil, and floor. And then how to deal with the workspace variable, kind of how to clear them, how to save them, how to load them again. And then how to create array. So we have different way to create array, how we can do that. And then if we have array, which function we can use for that array. Of course, we have so many, but just this is the ones I explained in the course. And then for the 2D plot, how to create a 2D plot, and then how to kind of advance the 2D plot using the annotation and the labels, for example, the title, the xlabel, ylabel, etc. And then the logical function or the logical operation which we are thinking, we give a condition and then we think, is this condition is true, it means 1, or false, it means 0. And then the if statement with the 3 forms for if. And for the looping, we have the for loop with the normal for loop or nested for loop, and we have the while for loop. And then how to read data from a file and how to write data to a file. If we have a matrix inside, how to write that. And then if we load the data from the file, so some of the data is missing. And what if the data is missing and we need to replace the missing data, because MATLAB defined the missing data as nan, how to replace it with, for example, some value like 0. And this is the input and the output function. So how to input, make the user input the variables or input the strings or display a text message using the display command. And then how to make a user-defined function inside our code to define the function to do some certain job, to kind of minimize the length of our code. And then finally, we use several characters inside this course. So when we can use the parentheses, when we should use the square brackets, when we should use colon, when we use the semicolon, something like that. So I'm going to cover this in this video. Please keep watching and let's start. So as you can see here, I split the window between the manual on the right side and MATLAB on the left side. So we can check which part I'm going to explain, and then if we have some comments, we can use MATLAB to do that. And then the first thing is arithmetic operation. I think arithmetic operation is very straightforward. So here we have the plus is addition and the minus and then multiplication, but we have some dot operation, which is dot multiplication or dot for the division or dot to the power. And we use this with array. So if we have array, so we need to use element by element. For example, multiplication, we use dot multiplication. And let's take example for that. So x is equal to from 1 to 6. It's kind of 6 element. I will not suppress, just show. So x is 1, 2, 3, 4 to 6. And then let's define y. And y in this time, let's define the random number with 1 row and 6 columns. And now we have x and y. If I need to multiply both together, if I just write x multiplied to y, this will cause error because this is kind of the vector multiplied to vector. We should write x dot and then multiply y. Now we can multiply every element by every element. And similarly, we have the division and we have the power. So if we just need to write, for example, x to the power y, so it should be x to the power y, and now we have every x raised to the power y, element by element. In the second part, we have the normal mathematical operation. So how to executing if we have some mathematical operation, which order we should follow. And the parentheses should execute it first, and then exponential, and then the multiplication and division, and then add and subtraction. The problem is the student in many times are confusing about when they should use the parentheses. For example, if we check this example, in this example, we have 3 plus 7 divided by 15 multiplied to 2. The correct answer, we should use the parentheses for the numerator and denominator. For example, if we have this 3 plus 7 divided by 15 multiplied to 2, if I write the correct answer, let's write that one. So I write 3 plus 7 and then divided by 15 multiplied to 2. The correct answer is 0.333 because it's 10 divided by 30, it's 1/3, it's 0.333. But if we use the wrong place for parentheses, or if we didn't use the parentheses at all, it will be wrong. For example, if I write 3 plus 7 divided by 15 multiplied to 2, in that sense, they will start estimating 7 divided by 15 first, and then multiply to 2, and then plus 3. If we test that one, we have a wrong answer. This is 3.9333 something. And even if we use the parentheses only for the denominator, also it's wrong answer, because in that sense they estimate this 15 multiplied to 2, it's 30, and then divide 7 to the 30. It should be 10 to the 30. And again, if we remove the parentheses from the lower part and then add the parentheses only for the numerator and press enter, also is a wrong answer, because in that sense they estimate first this one, which is 3 plus 7, which is 10, and then 10 divided by 15, which is the around this part, around like the 2/3, and then multiply to 2, it's kind of 4/3. 4 divided by 3 is 1.333. So the correct answer is that one, because if the numerator is the plus operation, so we should use numerator, and in denominator it's multiplication, we should use parentheses, or we should write as this. So we can write, instead of like multiplication, we can use divide by divide, and then we have the correct answer. So please remember this order, and please figure where you should use the parentheses. In the safer case, just use parentheses like whenever you wish. And when you check that you suspect we should or not, so please use parentheses, but sometimes some question is use the minimum parentheses. If we check the third part is calling about how to managing the command window here. For example, the first one is CLC, which is cleaning this part. If I write CLC, it will clear what I wrote now. And if I need to find the help about something, the easiest thing is to write, for example, help, and then the name you wish. For example, if I need to write help about pi, just help about pi, and they will explain, give something about that. You can click documentation to find documentation, or you can find doc and then pi. So if you just write doc and then pi, a new window, and press enter, a new window will open which have some document. And then short, for like the format short and format long and format bank, is how to show the number. For example, the answer here, it is 0.333, it is 4-digit, this is format short. If you need to show in 2, you should use format bank. For example, I will show one, format and then bank. So format bank is converting to 2, so if I show again answer, it is 0.33 only, 2 decimal. So I prefer to show the format short, and format long is showing 15 digits, and format like short G, it sometimes is useful if we have the number with the e to the power something. So for example, if we have 1.12 e to raise to 2, which is equal to 112, then in this sense we should use the format G to reformat the number. And for mat compact and for mat loose, it means that if we need more space in the command window or just the short space. If we write format loose, and if we write answer, you can check the difference between this answer and this answer. We have a big format. We write like format, and then if we check the arithmetic operation, I think you just need to remember that about the by, the square roots. For example, the by we write by, the square root we write square root, and or we can write to the power 0.5, but this is common mistake. For example, if I wrote, for example, we have the answer here, and the answer is 0.33. If I need to take square root for that, let me show you. So x is equal to the square root of answer. So I will store the square root of answer. So it's kind of 0.5774. If you need to have the same things, for example, y will store the another things, which is answer to the power. If you need to write that, you can write to the right 0.5. It's correct answer, it's the same. If you also wish to use, you should write answer with to the power, and then you should use parentheses 1 divided by 2. Please don't forget the parentheses. Some students also many times forget to write that. We have correct answer. If we repeat that and just removing the parentheses, which means that the answer will only have the power to 1, and then the answer will be divided by 2. Here we have a wrong answer. It's not exactly the same. So and then about the nth root, so for example, we write nth root x comma n, and then like the exponential x e to the power x, it will be exponential x, and then absolute, it will be abs x, and then len, it will be log, and log, it will be log 10, and then factorial, it will be factorial x. And remember, this is sometimes confusing. Let me clear the screen, CLC, and to understand the remainder, let me explain for you. For example, if I write remainder of 13,5, the answer will be 3. Some people don't understand. Let me explain for you. 13 divided by 5, it's 2.6. It means that we have, inside 13, we have full 5, and part of the 5, which is 0.6 of the 5. So it means that if multiply to 5, the answer will be 10. Or 13 minus 10, the answer will be 3. This is the remainder. And then we need some like trigonometric function like the sine. We use sine or sine d based on if x is in radian, we should use x sine, and if the x is in degree, we should use sine d of x. Similarly, cosine, tan, cotan, and then the inverse, like inverse sine, inverse cosine, inverse tan, inverse tan, it would be a sine. So sine inverse, it's a sine if we need to receive the angle in radian. But if we need to receive the angle in degree, we should write a sine d. So the angle we will have, it will be in degree. And let's consider about the round. The round is kind of converting the decimal or real number with the decimal point to integer number. So for example, we have 4 types of rounding. The first one is round x, the second is fixed, the third is ceil, the fourth is floor. Everyone have a different concept. For example, the round is round to the nearest integer. For example, if we have 2.8, round 2.8, it will be 3, round 2.2, it will be 2, round 2.5, it will be 3. But if we consider fix, for example, if we fix, it's round towards 0. So for example, if we think about round 2.8, the nearest integer in the 0 direction is 2. And the ceil, it's round toward infinity. So for example, if we try to round to ceil 2.8, so if we write ceil 2.8, the answer will be 3. If we write ceil 2.2, it will also be 3 because both the nearest integer toward infinity is 3. And the floor is rounding toward the minus infinity. For example, if we check that 2.8 and we write floor 2.8, the answer will be 2 because 2 is the nearest integer toward minus infinity, and for that 2.2 also the floor of 2.2 it will be also 2. I hope you understand that. It's very clear. And the next part is kind of about using clear some variables, and this clear some variables and then save and then load. It consider about the variable defining in the workspace. So the workspace, they have variables, and sometimes we need to remove all the variables, or we need to remove one variable, and sometimes we need to save all variables, or we need to save some variables, and we need this variable later. For example, you do some operation here and you need to save this variable and load again. Let's consider the first one, which is save. We can save this and return it back, but all is kind of similar. So we have 10 and then x, y, z. X, y, z is the same, but answer is 10. Let's store them and let's check. So for example, if we need to save, just to save all of these variables, you write save and then file name. And they will stored in this location, the current folder directory. If I wish to change, for example, in download, and then select this place, to save the file, just write save and then the file name. So for example, all variables, and we can put the extension and we can leave the extension, just press enter. So if we open the folder now, which is download, we can see all variable here. And if we need to save some variable, for example, answer and a and x, so I can write save and then some variable, and then I will select a and s and then x and press enter. So now we have saved only the answer and x inside some variable. So now if I need to clear, we have two options. Clear for selected parameter. For example, if I need to clear y and z, I can write clear y, z and press enter. So y and z gone now. If I need to clear all the variable, just write clear and all variable will be cleared. And if we need to load the variable we just saved, let's first load some variables. So I will write load, and from that load I will write some underscore variable, and if I press enter we will have the answer and x because we save only these two inside. If I clear the workspace again and let me load all the variable using the all variable file, so I will load and then all variable and press enter. Now we have all the variable load again. What if I need to load only y and z from all variables? So let me clear first and let me load and then all variable, and let me load y and z only, so we can load some variable from all variables. This is about clear some variable, save and load command for that command window. Let me clear and clear the variables, CLC again, and then let's check what next. In this part, we need to create array, and there are several ways to create array. For example, to create array, just we can open square brackets and put the number we wish. For example, we can open parentheses like that and just write 2, 3, 4. Once we write with a space or comma, it is column vector. If I just do that, it would be just a column vector. If I need to create, like for example, the 2D array, I will write x equal, for example, and then I will define 2, 3, 4, and then semicolon to give the second row, and maybe 5, 6, 7, and then press enter. So now we have 2 rows, 3 columns. And we can use a colon to create some vectors. For example, I can say, for example, from 0 with spacing 2 till 10. If I just press that, so it starts from 0 with a spacing 2 to reach 10. And if I didn't mention the spacing, for example, from 0 to 10 and press enter, so it will take one increment every time. It's kind of the spacing. And the square bracket is optional. For example, I can write again from square bracket 0 to 10 and close square bracket, both giving the same option. So using square brackets is optional with the column. And let's consider the line space. Line space is considering from the first to the last with how many elements. So we can write line space, for example, from the start 0 to the end, for example 100, and number of elements, for example 5. If I do that and press enter, so we'll have 5 elements between 0 to 100. This is the number of elements. But if I didn't mention the number of elements, so number of elements will be 100. So if I just repeat and just remove this and press enter, I will have 100 elements between 0 to 100. Okay, let me just clear CLC and then check again. We have 0. So 0, 1, random is almost same concept. So for example, if I write zeros of n, it will create square matrix or element are 0. If I create zeros of m comma n, it will create the kind of the matrix with m rows and n columns. For example, if I wrote zeros of 3, it will create the 3 by 3 matrix or element as 0. If I write zeros of 2 comma 3, it will create the 2 by 3 array or matrix, all elements are 0. Similarly, if I wrote 1, it will be the same. The I, if I write I, it only creates the square matrix. For example, if I wrote I4, it will create the 4 by 4 matrix. All elements are 0 except the diagonal. The diagonal will be only 1. And random, so random, if I wrote random of, for example, 3, it will create a random array. This is 3 rows by 3 columns, and the number ranged between 0 and 1. If I wrote random of 2 comma 3, it will create the 2 rows, 3 columns, random number between 0 and 1. Random integer is quite different or quite unique. If I just write random integer of 10, so 10 kind of the maximum number, so we find or the MATLAB will generate a random number between 1, I said before 0, it is 1 to 10. So it will generate the random number between 1 to 10, and it will be only scalar. So if I press enter, this is random number. If I repeat again, it's random number. But what if I need a square matrix of random numbers? In that sense, I will write the maximum number is 10, and for example 3. So it will create 3 by 3 matrix, the range of the number between 1 to 10. What if I need 2 rows by 3 columns? I will repeat again and write 2 rows, 3 columns, press enter. So we will have the random array, 2 rows, 3 columns between 1 and 10. What if I need the random range not between 1 and 10, for example, between 50 to 100? In that sense, I will write random I, open like the parentheses, and then write the square brackets, and then write from 50, comma, to 100, close the square brackets, comma, and then the size. For example, 2 rows, 3 columns, and close, enter. Now we have the random number between 50 to 100. If I repeat again, I will have the random number still between 50 to 100. So this is the random and random I. We finished that part. Let's clear the variables, CLC, and check the next. In the next, now we can generate the array, but what kind of function we can use? So for example, you can estimate the maximum, minimum, the sum, the mean, and the median. But sometimes it's confusing the difference between the vector and the matrix. Let's consider an example about that. So if we generate a vector x is a random number with a size 1,6. It means 1 rows, 6 columns, and press enter. So now here we have 6 random number. For example, if I need to know what's the maximum number, I will write just maximum of x, and press enter. Now the maximum here is 0.9593, so they can generate that number for us. Of course, if we write the minimum, we will have the minimum number, which is like the 0.2 something. If we need the sum, it will take the summation of all elements. If we need the median, it kind of the median number for this. The mean is kind of the mean for this. So for example, if we check the mean of x, this is just the mean. What's the mean for these numbers? It's kind of summation divided by 6. It would be the same. So if we write sum of x and then divided by 6 element and press enter, we will have the same mean, because the mean is kind of summation divided by the number of elements. So for a vector is very easy and we can understand that. The problem sometimes occur with the matrix. For example, if I generated the random integer matrix with the maximum number to 25, and let's use like 4 rows, 6 columns, 4, 6, and then press enter. So now we have here 4 rows, 6 columns is a random matrix. If I wrote maximum again for this ANS, let's define again this one inside a variable called y. It would be easier instead of using ANS. So y is equal to this. And if you check now that this is random, so randomly again, they create another one. If I just say the maximum of y, and I press enter, it will not generate one number as a maximum number. No, it will check the maximum number for every column. So the output is a kind of a vector for every column here. For example, for the first column, 2, 14, 20, and 24, the maximum is 24. 4, 15, 12, and 1, 15 is the maximum. If we check here, 20 is the maximum. If we check here, 16 is the maximum. If we check here, the 19 is the maximum. If we check here, 23 is the maximum. So this is kind of like that. If we have a matrix, 2D matrix, and then we use only maximum, it will generate kind of a vector for the column direction maximum value. But if we need the whole maximum, we should write maximum of y and then press enter. So if we check this one, the maximum number is 24. If we check here, or if we check the vector, we can find that the maximum is 24. Similarly, if we estimate the mean for that one of y, it will generate the mean in a column direction. But if we need the whole mean, we should write mean of y and press enter. I think now the concept is clear. If you have a vector and just use a maximum, minimum, mean, etc., it will generate one scalar, one value. But if you have the 2D matrix and you use maximum, minimum, mean, etc., it will generate a vector to this value in the column direction. If you need the whole, for example, maximum, minimum, the whole mean, etc., you should use maximum, maximum, minimum, minimum, mean, mean, etc. We finished that part. Let's clear the variables, CLC, and check the next. If we check here, this is the 2D plot. And 2D plot is very important because as a user of MATLAB, usually if we have a data, we should show the data in a figures. So the plot is very important. And for example, we have here the plot xy, plot y, plot x1, y1, x2, y2 is kind of showing the pairs of plot. Let's take example. So let's define x as a line space between 0 to pi, and number of elements is 30. And let me suppress the column because there's so many. And let's define y as a sine x, and let's define that as a cosine of x. And please remember that I didn't use sine d or cosine d because this is from 0 to pi. It is radian value, so we don't need to use kind of the sine d or cosine d. And then if we need simply to plot, let me just minimize that part, and let's plot x comma y. I press enter. and then we have the figures showing the plot. Let me minimize this a little bit. Okay, so now we have the figure for the sign x and y. What if I need to show both? So I can easily like plot and then x comma y, the first, and then x comma z, and this is the second. If I press enter, now we have in the same figure, we have two plots for sine and for cosine. The things sometimes happen is, for example, we need to advance a plot, for example, to change the line color, line style, or marker style, or we can change the line width, marker size, or marker edge color, or marker sphere color. So we need to change these things. Of course, we can do that. For example, if I repeat again, plot, and then x comma y, and then, for example, if I need to draw that as a dash line is dash dash, and for example, red line, it will be R. Let's use the marker as a cross, so it will be X. And then let's draw the X versus Z. And let's, for that one, use the following. For example, we need to show only the marker as, for example, plus. We don't need to show the line, and we need this line to be magenta. And then I need to, for example, make the line width for these figures. For example, I will write the line width, and let's give me the number 1.2. If I press enter, now we have this figure. So in this figure, we have so we don't know which is sine, which is cosine, we may forget. So let's, the first is sine and second is cosine. Let's write the legend. And then let me write, the first one is sine, and the second one is cosine, and press enter. I'm misspelling the legend. So now we know that the red is sine and this one is cosine, and as we check, we order here red for the sine, we have the red for sine, we have dash dash is dash line, and we have the cross marker here. In the second one, we order only the plus sign and magenta, and we didn't mention the line type here, so it is hidden line. If you define the marker, you should define the line unless the line will be none. So we have this legend. What if we need to kind of put the title it will be just title, and then just write anything. For example, we can write x, y, z plot. And if we press, we have here x, y, z plot. What if in the x-axis we need to write x labeled? For example, we write x label, and then we write just x, and press, we have here x. And what if we have y labeled and with a value of y and z? And if I press enter, it will have here y, z. And what if I need to, for example, show the x limit? For example, this is from 0 to 3.5. What if I need to show only to 3? So I can write x limit and then put, for example, from 0 to, for example, 3. And then enter, so we have the limit to 3. And what if I need to change the limit from minus 1.5 to 1.5? I will edit the y limit, which is from minus 1.5 to 1.5, and press enter. Now we change the y limit. And then what if I need to change this, like the legend location? So for example, we write the legend location in this is the default. What if I need to find the best place? For example, I will do that. Let me write the legend, and then I will add for that the location. And for the location, I can write many things. For example, the best. So the best, MATLAB will select this best for us. So he saw that the best here is the southwest corner. What if I like maybe in the south? I can edit and make that south. So you can change. So here's the northeast, the north, northwest, and then this is the west, this is the east, and here's, so you can select where the place you need to change. And what if I need to show the grid? So just like the showing the grid, I can write grid on. So if you check now, we have the grid is on. Of course, grid off, it will close. Hold on is very nice because if we draw here and we need to repeat something like that, for example, if I write a equal to tan of x, now we have that, which is like the a, and we need to show here. If I plot now x comma a, it will remove this plot, it will close the figures, and it will not show at the same. If I need to keep, I should write hold on, so it means keep this figure, I need to add, and then plot, and then x comma a. So now we have the tan figure. But I should write hold off to stop. Let me repeat again, plot x comma a. If I now, I close the hold off. If I press OK, now the previous figure was closed and the new figure was open again. So this is the problem, is using different plot. If you need to keep the command, you should use hold on or hold off. And then subplot. Subplot is as shown here. You can divide the figures to several plots. For example, I can divide this plot to two, like 2 rows, 1 columns for sine and cosine. I can do that. I can write subplot, and then I can write 2 rows, and then 1 columns, and the number 1, it means the upper one. And then I can write plot of x comma y, and press enter. Now I have the first one. And then I will repeat the subplot, but instead of 1, it should be 2. So now we have the lower one, and then I will write that instead of y, it will be x versus z. So we have in the upper one the sine, and the lower one is cosine. And the figure, if we need to keep that one and draw the tan in the different figure, so I will write figure. If I do that, they generated a new figure for us and keeping the previous one. And then in the new one, I need to plot, for example, x comma a. So now we have the tan is showing here. If I need to close, so we have 2 figures, 1, 2. 2 is now activated. If I just write close, it will close the active window. If I write close, it will close the active window. If I need to close all, I should write close all. It will close all the figure window here. So I think we finished this part from these comments. Let's clear the screen and go to the next part. So let me write clear, CLC, and let's do the next. And the next part is the logical operation. And in the logical operation, we can check that. Let me maximize the window. In the logical operation, it is kind of creating condition. For example, we can say less than, it means, for example, A less than B. So we know the value of A, and we know the value of V, and we can have the output, which is true, or 1, or false is 0. For example, let me define, in this part, let me use the live script. Let me use the script, or live script is better. Let me use the script. For example, I will define A equal to 3, and semicolon, and then P defined as a 5, for example. And if I just write A is greater than B, so A is 3 and B is 5, is that true? No, this is false. If I just run this one, first, if you run the script, you should save it first. So we run here, let's try the code 1, enter. So now the output is say this is logical 0, it means false, this is not correct. What if I said this is less than or equal? So if A less than or equal B, and then run the code again or press F5, now the output is 1 because this is true, A is less than. So it is less than or equal, greater than or equal, and we have equal. So equal is kind of equal sign. So if we write equal, it means this is does A equal B, and if you run the code, press F5, the output will be 0 because that's not true. If I just change it equal to not equal and then press F5, the output it's 1, it's mean true because A not equal B. Sometimes we have and or, which comparing several commands. For example, I can check if A less than B and C equal D, and similarly instead of and I can use or. So the most important from this logical operation is to create condition. And why we need the condition for the next part? The next part is we need the condition because of the if statement. So if statement is if and then condition. And if has three forms. If condition, do something and end. If this condition is true, this part will be done and then end. And if the condition is false, this part will not be executed and then go to end directly. The second one is if condition, we have else and then end. So for example, here we have the condition. If the condition is true, this part will only be executed. But if the condition is false, this part will be executed. The third form is if condition 1 and then else if condition 2 and then else and then end. For example, if and then condition 1 is the condition 1 is true, so this part will execute it and then go to end directly. If not, so he will check the second condition. If the second condition is correct, he will execute this part and go to end directly. If not, he will do this and then go to end. For example, if we have like the x equal to x squared plus 4 in case if x is greater than 0, where the y equal to x minus the minus x in the case of x less than 0. Let me write the code to do that. Let me first clear CLC and let me remove this and write this one. So for example, I will define x with any value. For example, x equals 3 and then semicolon. And then I need to write the if condition. So the if condition, it will say if, and then if x is, the first one is greater or equal 0. So if x is greater or equal 0, what will happen? In that part, you should execute the first part, which is y equal to, and then x squared, it will be x to the power x squared, it means x to the power 2, and then plus, and then 4. And enter. But what happened if the x is not greater or equal 0? In that sense, we write else. Else. Some students write else and then write here x less than 0. That's wrong. You don't need to write that. Just else, press enter, and then in that case, the y equal to minus x. Press enter, and then write end. We finish the code. And once we finish, just press F5. If you press F5, because x is equal to 3, it means greater or equal 0. So they took 3 to the power 2, it means 9 plus 4, it means 13. So we have 13. If we change that and make it minus 3 and then run the code again, so the output will be 3 because y is equal minus x and x is minus 3. So minus 3, it equals 3. We have this part. So we could understand about the if statement. The next part is that, let's clear that one. CLC, and also let's remove the code here, and then let's check the next. The next is for loop. In the for loop, we have the normal for loop, for, and then we have the index from the start with the spacing to the last. It's similar to when we create the array using colon, and then we have the end. And we have the nested loop with two indices which should be different. So we can't use I and I, we should I1 and I2. Let's understand how for loop is working. For example, if I just make for and then I equal to from 1 to 6. And of course, if I didn't define the 1, it will be 1. So if I write here 1 to 6 is the same as just 1 to 6. And then I will press enter. For loop, what do you need? I will just display I. And then I will press end. And then let's run this to understand what will happen. If I run this, it means that when I equal 1, display I, it display 1. And then go again to increase the I from 1 to 2 to 3 to 4 to 5 to 6 to reach the end. So every time the I increasing, so I was 2, display 2, and then I3, display 3, I4, display 4, etc. So we have 6 loop and display I. This is very nice. But what if if I have x, for example, let me generate x, and let's create x with, for example, random integer number, and this random integer number with a maximum 20 with a size 1 rows, 6 columns. And if we have this x, so it would be a random number. And what if instead of I just write inside that x of I? What do you think will happen? If I just run the code now, please remember that this is x, which the random number is 17, 11, 20, 2, 9, and 3. So we have here 6 element vector. And then when I equal 1, he printed x of 1. So x of 1, it means the first element 17, so he prints 17. And then when I was 2, he print x of 2. X of 2 is 11, so he print 11. And then when I was 3, so he print x of 3, it means 20, so he print 20. So when we need to loop for the element of x, so x here is 17, 11, 22, 9, 3, and we need every time to go there to display or check a condition, we can do that. For example, instead of displaying that one, let's try to find if the number is greater than, for example, 10, because we generated random number from 20, so it will be from 1 to 20. What if I need to only display the number which is greater than 10? So for example, if I said if and then x of I is greater than 10, what do you need? I just display this x of I. So it will print only the x of I. And then I will end the statement of if and then run the code. If I run the code now, please remember that this is random, so we have a new array which is 21, 16, 17, 18, and 2. And if you check here, he print only 20, 16, 17, and 18, and he skip 1 and 2 because they are less than 10. So we can create a condition about the loop we loop for it. So I hope you understand that. So this is the first part. We can understand this is a vector. Let me comment that part. And then let's think about how if we have the, for example, the kind of a matrix 2D array. And for example, for the 2D array, let's generate x again, just generate x, which is random integer. The maximum is 25 value, and the size is, for example, 2 rows, 4 columns. If I press enter or run, he will generate x. Let's try that one. So now we have x is a 2 rows, 4 columns with x. And let's create a for loops. For example, I will create for loop with index 1, which is 2 rows. I will just create from 1 to 2. So this loop is kind of looping for 2 things. And then I will create inside that one another loop, which is I2. This I2 can loop for 4 columns. So I will write 1, 2, 4. And then just I will display I1 and I2. I can do that using the plus and then I2. So I can show this I1 and I2, but I'm afraid that he will show that as summation. So I can write plus and then value. And then I will just end the first for loop and just end the second for loop. And let's check what will happen here. If I just do that, just run. So he just generated I1 plus I2 because he submit both. Let's try to overcome that. I can write here, for example, I1 equal, and then close, and then plus, and then let me write I2 here equal, and then let me write here plus I2, and then let me give a space here. Let me run this code again, and if you check here, let me give a space, more space, and run the code again. If you check here, when I1 was 1, so I1 was 1, and then I2 was 1, and then I1 is 1, I2 is 2, I1 is 1, I2 is 3, I1 is 1, I2 is 4. So it means that when the I1 was the first I1 is 1, so he looped 4 times for the I2. So it will keep the I1 value from 1 and then looping 4 times for I2. And then when I1 change it to 2, so he will loop again 4 times. So I1 is started from 1 and he looped the inner I2, and then he changed I1 to 2, and then he looped 4 times for I2. Now we understand this concept. What if I need to loop for the value for the, for example, for the x, I need every time to print the value of x. For example, I can say here, comma, and then x element. It will be plus x of, let's write here, I1, comma, I2. So in this time, he will print, and every time the index, for example, 1, 1, it means, for example, here the first row, first column, this element. 1, 2, it means the first row, second column, this element. And then 1, 3, it is the first row, third column. Let's try. Let's run the code. The error here, this is not, we should not use comma, it is just plus. So if I run again, we can check here. When I1 equal 1, I2 equal 1, so the x element was 24, as I mentioned, this is the first element. And then when I1 was 1, I2 equal 2, the second element is this one. And then when I1 is equal 1, it means the row 1. And this is column 3, so row 1, column 3, it means 9. And the row 1, column 4, it means row 1, column 4, it means 1. So this is kind of how we can loop for the, like the element of the matrix. So now we have the matrix here, and we can loop for every element of the matrix. For example, if we estimate the mean, and then we can find what is the problem for that mean, we can do that, or what's the maximum number. For example, instead of random number, I can define like 2 rows, 4 columns. For example, 2, 4, 5, 9, minus 1. So now 4 columns, let's have semicolon, minus 1, 10, minus 2, 5. So now we have 2 rows, 4 columns. And if I loop again, for example here, I can see all the element, but this time it's fixed because we enter the value not a random, it's fixed. So if I have this matrix and I need to know the maximum, as we know, as a whole maximum, so I can write maximum of x. If I press enter, for example, like this one, I will have the maximum which is 10. And if I check here, yes, the maximum is 10. What if I need to mean, and I have another mean, and let's store that in the variable, for example, m underscore equal. So now we have this mean value. If I run now, I have the mean which is 4. So what if I need to count how many element is higher than the mean? For example, if I check here, 5 is higher than mean, 9 is higher than mean, 10 is higher than mean, 5 is higher than mean. So we have 4 element is higher than the mean. How to do that? To count, we should create first counter. So we should write counter equal 0. And now we here loop for the element. We don't need to display that now. So I will just shut down this. And what I need is to check. This is looping for row, looping for column. So we loop for every element. And we need to check which element is greater than the mean and which element is not. So if I said if, and then the element of x, it should be defined by rows and columns. So I1, comma, I2. And if this element is what is greater than the mean, which is m underscore, what should happen? In that sense, please count the element for me. So the counter will be equal the counter plus 1. So increase the counter by 1. Else, and then do end. If I run the code now, I didn't suppress, so I need you to check what will happen. If I run the code now you can check that the counter started with 0 and then increase it to 1, because when we go here, you find 5 and then 9 and then 10 and then 15. So increase it from 0 to 4. Now we can find. For example, let me change this 10 to be only 1 and then run the code again. So I have here the mean changed also. So for example, if that mean changed to 2.8, still the number of element is 4. For example, if we check here and we make, for example, this is 100 and then run the mean, and now the mean is 15. And because the mean is 15, only one number is greater than that, so the counter count only 1. So this is how we can manage the things here. So the counter can find how many element which kind of satisfy the rules or the condition we can find. So anyway, the for loop, we can use only the normal for loop if we like loop for a vector, and we can use the nested for loop if we need to loop for the matrix. And let me just clear CLC. And let me just wipe out everything here, and just while. The while is kind of looping until the condition is finished. For example, if I write x equal to 0, so the first value of x was 0, and then I will set while the x is less or equal 10, what will happen? Just display x. Let me suppress the value of x in the first element here and just press after that end, and then let's run the code. If I do that, this code will never stop. Why? Let me use Control C to terminate the code. Click here and then Control C. Now the code terminated. It's terminated because x is 0 and the x will never change, so it will looping forever. If I need to adjust that, I need to write x equal every time increasing the x, like the counter increasing x every time. And then let's run the code this time. So in this time we will have several x. So let me suppress this so you can just display the value of x. If you check here, the value started with 0 and then 1, 2, 3, 4, 5, 6 up to 10. When the x reached 10, it stopped. So this is very simple. We just put a condition and loop until it satisfies the condition. And why we need the while? Because sometimes we need to loop, but we don't know how many loops we can do. But for loops, we can know number of iteration using the last value minus the start value dividing by the spacing plus 1. So by this, we can know how many loops we can do. It's clear. And then CLC. Wipe everything and then check the next. In the next, it is kind of how to read from the file and how to write to a file. So for example, if we open this folder, which is download, we can find the grade Excel here. And in this grade Excel, we can find that we have two spreadsheets, the week's grade for the 4 student, 1 to 4, and the week 10, so they have the grade for 10 weeks, and we have selected grade, which is this 4 student for just 4 weeks. So for example, if, let me just minimize this a little bit and minimize this a little bit and keep it here so we can check the Excel file. If we check here, we can read from file using the read matrix. And in the read matrix, we have two forms. The first one is the simple form, which is x equal to read matrix and then input the file name. And the second one is read matrix with some option. For example, I can specify the range and I can specify the sheet. For example, if I need to read from the second sheet here, which is the selected grades, this is the name, selected grades, and I need to read from A2 to D5. Let's do that. Right, x equal to, and then read matrix, And then from readmatrix, I will put the file name, which is the grade underscore excel.xlsx. And then I will specify the range. And this range should be between these quotation. And then the range, for example, from A2 to D5. So it will be here from A2 to D5. And then I should specify the sheet. So I should write here the sheet, which should be selected grades underscore grades. And then I will run the section. If I run the section now, we imported the data, which is 88.4 and etc. And if you notice here in this Excel, in this cell, we have like unknown value or missing value. So the missing value was replaced here with none. But what if I don't need to do that? I need to replace the missing data using 0. So if I press enter, I can do something which is, let me show here, down here. If I said isnan is a function to know where is the location of the nan value of x. If I press enter, so all 0 except this value with 1, which is this nan. So if I need to replace this, all what I need is to write here x of is nan and then of x and then equal to 0. And then run the code. This will replace all the missing data, as you can see here, from nan to 0. So isnan is kind of determining where is the function or where is the variables have a nan value, and then we kind of using the x of that, like that we know the position or the index, and then we equal to 0, so we change the value to 0. So I think this is the read from a file, and if I need to write to a file, so all what I need is just write, and then the array, for example, this x again, and then I can specify the output value, and we have several things, which, for example, the range or the sheet or the delimiter, for example, tab or space or etc., or the write mode if you need to append or if you need to overwrite to write in a new folder. For example, for x, if I estimated the y, which is, for example, in this case, we have, let me just suppress this one and this one. And let me here estimate y as a mean of x. So because x is a 2D, if I run the code now, y is kind of the vector. If I need to keep that one with some header with a student name. So I can, for example, find the header of the student name. I can define them, which is equal to the student name. So now we have the header. I can append this header and this y in a folder. How to do that? It's easy. Just what I need is to write matrix, and then I need to write first the header. So all what I need is to specify the header, which is the matrix, which is header. And where's the file? For example, output. This is the file name, and let's do that as a CSV file, and then close this file. If I press run now or F5, so if I go there, I can find output.csv. If I open that file, I can see here and John, this is the name, so we know that file. And then let me write again in this time. So let me just copy and just paste. And instead of header, this time I need to write y, but I need to add for that file. So in that sense, I should use here the write mode command. So here I should write write mode, which is append between the brackets, between the quotation, and then run the code. Once we finish, if I again open the folder, which is output, We can check here that we have here the names and we have here the mean, which is 85.37 something. So now we have this output row here. I think they are very nice, and we learn how to use some specification about the range. Of course, this is for the Excel only. The sheet, if we have different, like Excel with different sheet, and we need to specify the sheet, and then the limiter, as I mentioned before. Let's clear everything. So CLC and clear, and wipe everything here. And let me just close these first. And let's check what next. In the next part, we need to input something or output something. So the input is kind of input from the user defined. So for example, x equal to, and then I can write input, and then write a message. For example, enter a number, and press enter. So now we need to enter a number, for example, 100. So now we have 100. And then I can write name, which is equal to, and this time input, and in this input I will give a message, for example, enter, and then a name. But this time this is string, so we should have the string to sustain that, and then I will enter my name, which is Salim. So now that we have here the x is 100, this is scalar with a 1 value, and we have the name is Salim. So I can display that using the text, for example, and display. For example, I can write text as a message, which is, I can say the name, which is I enter my name, and then plus to concatenate things, and then I can say entered a number equal, and then plus the value, which is x. If I do that and press enter, now we have the message which say Salim enter a number of 100. If I need to display that using display, so the display command is just display the text x. We can have display or just display, but for example, instead of text we can display just x or display the name. So this is about the input, like the for x string and display and everything. Let's clear and CLC. And the next part is the function. So the user-defined function, the function is very convenient. We should have the names, which is, for example, the function, and then we have the output y1, y2 to yn. It should be inside this square brackets. And then the function name, for example, my function, and then the input for that function, for example, x1, x2 to xn, and then the end, and we have the block of code here. And the function could be inside the code, so we just call the function to run the function, or the function could be in the function file, and the function file should be a script file with extension .m, and the function file should have the same name with the first function in the file. But if the function inside the script file, it should be at the end of the file, so at the end part, as you can see here. For example, if we define two functions, for example, if I define x, which is random number from 1 to 6, this is just a random number. And if I define y as a random integer, for example, the up is 25, and then also 1 row, 6 columns. I defined x and y, and what if I need to make a code to estimate the mean, maximum, and minimum for the vector? So I can press enter and then have a function, and it turn it blue, and then we should give some input, some output from the input. For example, this is my function, and then my function will take the input. The input is a vector, for example, here in our case. And if we have the vectors, so we can estimate the mean for that vector, which is equal for that one mean of vector. And please note that I use underscore because this is mean is a function, but this mean is a variable. We can't use the name of a function for the variable. So this is the mean, And for example, I can have the maximum, which equal to the maximum of vector, and I can have the minimum of x. So this function can estimate the minimum, the maximum, the mean, and then once I finish, I will just write end. And these are the outputs, so I will define here as a mean, maximum, and minimum. And if I just run that, I will not have output because the function was not called. So if I just run, I will have random x, random y, but I didn't have calling function or output from the function. To call the function, just please copy this, Control-C, and paste it here, Control-V, and rename the input. You can keep it, but I prefer to change for x and y. For example, mean x, and then maximum x, and the minimum x. And for example, the input is x. So I will input the function x, and x will go to vector, and he will estimate the mean for vector, maximum for vector, minimum for vector, and return this mean again here. It will store in mean x, maximum x, and the minimum x. And I will do that again for the y. So here I will have the mean of y, the maximum of y, and the minimum of y if I give y. If I just run the code like that, so the error here, because this is x, we should write as a vector because x is not defined. Just run again, and now we have all of these. Let me just suppress these things here, and then also suppress this one. I will show you y, and let me show the x and show the y. If I just run this code, let me just clear so we have a better visualization, and then let me just run the code again. So now we have this x, which is random value, and this y. If I just show the maximum of x, maximum of x is 0.9797, which is this maximum. If we check all, this is the maximum. And if I show the maximum of y, it will be 18. If I check here, the maximum number is 18. So here we can have the maximum, the mean, the minimum from all the function. I think this is a function, it's very straightforward, and it can save space. Instead of repeating the same command 3 times and 3 times here, it just once 3 times. So if this is the last page, and in this page, as you can check here, we use many characters. For example, equal, it's used for a sign. Equal is the logical thinking, it means equals. And it's kind of condition, and the answer will be 1 is true or 0 is false. And the percentage sign is giving comments. So if I just write percentage sign, this line will comment, and it will be green in MATLAB. I just highlighted in red which part we use. And then parentheses. So the parentheses will be used in 4 places. For example, if you define the arithmetic operation, so you will need a parentheses. For the line space, for example, when we define the line space from 2 to 10 with number of element 5, so we should use parentheses. For example, if we index x, for example, if I have here, let me show you x equal to, and then let me define 1, 2, 3, 5, and 9. This is 5 element. What if I said x of 5 is kind of slicing? It means first element, second element, third element, fourth element to the fifth element. So it's kind of the indexing of x. And we use the parentheses for the input of the function, as I just explained. And the column, we use a column in 2 places. The first one is to create the vectors in the case of column. And also if we need to select a range from x. For example, if we have x here from, as we mentioned, from 1 to 5 element, what if I need only the second, third, and fourth? So I can write x of from 2 to 4 and then press enter. So I have 2, 3, 5. This is kind of the medium element. So we can use for the range. And the square parentheses we can use in 3 places. The first one is to create a matrices. So we need to add square brackets. Or if we need to remove an element, so equal that element in the index that element and then equal to the empty brackets. For example, if I need to remove these elements from 2 to 4, I can say x2 to 4 equal to empty square brackets, enter. The x now is only 1 and 9, so they remove the inner element. And the third one is output of function. So in the output of function, we should use the square brackets. The semicolon is used in two places. The first place is to kind of suppress the output. Usually when we write that, we don't have the output from MATLAB. The second is to create row in a matrix. For example, if I define x equal to, and then I will set 1, 2, 3, semicolon, 4, 5, 6, and press enter. So we have 2 rows, 3 columns. So this is kind of separation for the row. And this like the 3 dots, it means continuous expression. So if we write, for example, a function or a code and it's very long and we need to continue in the next line, just write 3 dot and then enter. So you will go to continue in the next line. And the last thing is the double quotation. So the double quotation is kind of to create a strings. It is very convenient to do that. I think we finish now all the basics. I hope you could learn from that, and I hope you could summarize all the basic MATLAB in your mind. Thank you, see you, and bye-bye.